Now we're live. Live from downtown the Bay. Going. Okay. So.
Yeah, but I'd rather not.
No, it's not G, it's H.
Oh, it is H, yeah. I was looking at the wrong one.
You said G, and you confused me.
That's why I was looking at the wrong one.
You were looking at the wrong one.
Elena, whose group are you in?
Please.
Oh.
Why you suck?
And.
Who's your group?
I'm the only
My group.
No, who's one group?
I made it myself. You're fine.
There it is.
I'm kidding.
Okay.
Is it just random?
No, it's like all.
I picked it and then Peter and Rowan went and changed a bunch of stuff too.
I think you did a good job. It's like pretty like even.
I tried so hard. Olivia?
Olivia
Yeah.
from Ruby, no?
But
He's like a leader for it.
no, he's with me.
He didn't do anything.
He did not do a single thing. Dude,
Yeah.
he texted me and was like, "Do you need help with the game stuff? Like figuring out the games and the relays?" And I was like, "That's not our job.
Whose job is it?
That's Rowan and Peter. We're the groups."
Yikes, they have to do so much.
I know. But we got it done.
Chilling along with them at library.
Yeah.
Wait, where's Nancy? It's just, you know.
There's always something else. No. Oh, we did that.
Oh, that was really bad. I'm really bad today.
That's too really bad.
Okay, I've added a question to your notes. I'm gonna add another question. I would like you to find, I don't have the 10th thing done in it yet, so I'd like you to grab a partner. My only criteria is the partner cannot be someone next to you.
No.
To your right, left, or vertically, or horizontally. You can only go diagonally or more than one space away.
See my horizontal. Yeah.
I already think
I'm sorry.
Wait, what? There can't be no one behind you either?
Not directly behind you, diagonally behind you.
You know what? I'm just like waiting for that.
Yeah, you fucking get by.
Breaking. Let's go.
Oh. What?
Oh my gosh. You're gonna be actually in shock. Holy stuff. Like, no way.
It's expensive.
that makes it so really cool. Wait, for two?
What did you say?
Don't we just add something that's like that person takes out?
Yes.
Well, I don't think you're contributing right now.
Oh, yeah.
And it would be useful to write out the appropriate chemical reaction equilibrium that's going on. Just do one at a time right now. Sorry, what?
No, we mean like.
Oh, there is two different avenues to do it. Yeah, you just need to find one. What are you gonna do?
Wait, did you? She answered that for question. Oh, wait, that's right. So, I don't
I've never seen NO3SO4 in my life, and I would challenge you to find it on a shelf.
Oh, wait,
Oh, there we go. There we go.
Wait, Mr. Nicholls,
Yeah.
if you wanted to make it less soluble, could you just make it like decrease the surface area?
No,
If you want to make it less soluble, what you're essentially saying is you want to add more to a saturated solution. So there's the chemical equilibrium. You need to write out the chemical for a saturated solution. If you have a saturated solution, does crushing out the solid make more dissolve whole if it's already saturated? No.
Are you cheating?
does lowering the temperature make it less soluble?
You are not allowed to lower the temperature.
Oh, yeah, it looks like it is.
You don't know if it's exo or endothermic, so it doesn't matter. I mean, that's a clever answer, given I didn't give more context. But I'm just saying, the principle I want you to get to, you have to add something. So you're on the right track, but you have to add something.
Well, like, yeah, we like played on Monday, it will be the next one.
Here, you done? Done? What did you add? And what did that do?
It lowers the solubility of both of the compounds.
NaOH how does, oh, sorry. For the first one, adding NaOH would not lower the solubility. In fact, it might increase the solubility. It definitely would for the second one, though. I am giving you 2 more minutes, and then I'm going to walk by and ask you to explain your best idea. I'm giving you 2 minutes, and I'm coming around and I'm going to evaluate you. I'm going to give you a proficiency. Yeah. What? 10? Okay. Time. For just number 1, what did you do to decrease the solubility?
you asking us?
Yeah, I'm asking you.
Add Na2SO4.
Nope, that might increase the solubility.
What?
What did you add? Yeah, that would might increase the solubility.
What about
Check
just
solubility.
SO4?
What do you add for number one? Gentlemen, I expect you to be working on chemistry, particularly when you have wrong answers. Neither one of for the first one, neither of those ones would decrease the solubility. They might increase it actually. What do you have? What did you add for the first one?
I just got, is that wrong?
Oh, that's terrible. You had it right, but then you erased it, so now I can't remember.
Wow.
Confidence is more important sometimes. Okay, why does that? Right, so you had to add it with something. How does that in calcium that decrease the solubility? It's right. Now we're really stop. I want everybody to write down a correct answer. For number one, one thing you could add would be calcium nitrate, CaNO3. But I didn't hear an explanation why that works. So knowing that's right, I want you to now, I'm going to come around again in 2 minutes. I want to know why that works and your answer for the second one. You make it more solid, yes. This is a 2 era. You want to know that. What kind of science is that for you?
Oh yeah, I'm on strike.
Which means it does nothing. Don't focus. No, your answer is why does it okay, what are you guys working on? I didn't see you up there. Oh. Oh, okay, fine.
Yeah, I don't understand.
Oh my god, can I show you my lip balm?
No, don't show the lip balms. Discuss chemistry.
We're done.
Oh. Oh, okay. I thought you said you were discussing. You didn't know. So.
Oh, well, we discussed it, we still have
There is. Ours is wrong, so yours is wrong.
Yeah, we know. We've got different answers now.
Okay.
It's orange vanilla.
You guys know why though?
Nope. Because they're both soluble.
Yeah.
They both create a soluble solution.
Really think about what you learned about an equilibrium. What is this going to shift and where?
We should write it out.
More soluble, it's gonna shift it to solid.
I am writing it out for a reason.
Actually, saw this
It is useful to write it out.
Let's analyze this. Let's ask this. It's gonna shift.
very popular brand there.
It's gonna shift it.
Use your adding into the CAS.
That's
Oh,
probably.
you're not even just CA. Why do you have to do that? How does it get added to CAS?
Oh, no, not you. You got it.
Why not?
What do you mean?
Oh, to right side.
Right side CA, so then that left side. I would go that way.
Okay. I started here last time. I'll start here. Why does adding calcium nitrate work?
Because if you add more of the ions, then it lowers the solubility, increasing the concentration.
Nice. Which iron? Calcium. And what is the other iron? Sorry, that's my obtuse way of asking. Why don't you have to worry about the
I
next
don't
one?
know. Not my problem.
Did you see one of the kids donated $12 and the other kid added like
You're adding more of the calcium?
bits of the $12.
Why don't you have to worry about the next one?
Partner donated feel like something's being betrayed. No, but it's like, it's a good.
I may be being obtuse because asking, it's not a trick question. Nitrate's soluble with everything, so the only reason you had it is so it had it. It's a spectator.
Yeah, because you can't have
But like, if you think about it,
Okay,
all of the proceeds.
first group had it in one. I'm going to continue coming around. I'm going to ask you for either another compound in one that would also work, or you could answer the question for number 2. The reason adding calcium nitrate works is because you increase the amount of calcium, which shifts the equilibrium this way, which means more solid is performed, which means less solid by necessity can dissolve. If you have a solution that already contains calcium, a common ion, because this is all on the common ion effect, then it would be less soluble. The nitrate is a spectator. You only have it so you can bring calcium to the party. Like, you know, people that are like really good friends and like you like one of them, but you know you have to invite both to get them to come. So you invite the other one even though you don't like them. They're just a spectator. They don't add anything to the party. That's calcium nitrate. To get calcium to come to the party, they had to come with nitrate. I don't know if that analogy worked at all. So do number 2, or you could just give me another compound that would work for 1. There's multiple compounds that would work. Okay, another compound that would work? Or hold it.
What?
Another 2 minutes. I shouldn't come just right away. Give you time to think. Give you 2 minutes to think. 120 seconds.
What can you add? Yeah, sulfide what? Sulfide with what?
Was there a golf
S.
No. I want you to repeat this phrase in your head. Common ion.
What is a common ion?
Common ion. Okay, let me define common. What do you and I have in common? We're humans. I like how it just stops there. We're humans, we have nothing else in common. What? Yeah. We speak English, sure. We live at the same place, yeah?
We're all in the same room.
We're all in the same room. These are things between us that are, if you say in common, identical between the two. So, what was identical in our solution? The calcium. Calcium caused that to increase shift there. So what would be another compound that would work? Pardon? SH2?
No.
What?
NAS?
You're hold it. You're on the right track. In that if you added H2S, what is the common ion? S. So that would go up. It would shift it that way and be able. So in a hydrogen sulfide acidic solution, assuming it makes this, you have a common ion. What is another compound that would work? Nope. Oh, hold it. Is MgS soluble? Yes. So, yeah, it is. So you could also add, pick another color, MgS.
So it doesn't matter what the spectator ion is?
No, as long as it is a spectator, it can't react with, so the Mg can't react with anything else, so it has to be soluble. So this is the common ion, and then this is the spectator. And in this case, H2S, hydrogen was the spectator. Do this one, and I'll come around in 2 minutes. Starting there. Yeah, that's perfect. Oh, hold it. For which one? For the second one? Yeah, you got strontium. So strontium is your common ion. Yeah. Did you write? Is that SROH2? Excellent. Good.
Unless it was something outrageous.
Or I mean then.
I feel.
Oh wait,
Why would you add?
I mean, I didn't know this, but I've been meaning to put it up for ages, and I just realized now that we're in section, this is absolutely needs to be, yeah. And I've got another one that I also have to put up.
Is that right?
That's all.
Where's my key? Yes.
Oh my gosh, you can't say it.
SR, is it soluble?
Yeah.
Yeah, it didn't work.
Let's go.
Let's go.
Increase that amount, it's gonna shift it.
find.
We have it right.
Why do you never watch the TikToks?
I made one.
Okay, let me show you.
I need to move it.
More of one of the islands.
Mia,
I don't know.
you also didn't sign it.
Yeah, I don't.
You have to sign it.
Oh, that's why you. Okay.
There's no sound. This is a race marker. This is so equal.
Also, then, years from now, it can be legendary. And I'll tell students tales of me.
That is so mean.
Okay, I was going here. So what else can I have? Yeah, is strontium sulfide soluble on its own? Like, with its own? So, what's the common ion in strontium sulfide? Yeah, strontium, so it makes it perfect.
That's my art.
Number 3, NaCl has Cl. It is soluble in everything. So that means the spectators. Spectators don't do anything. So that will do it. So you need something that's going to do something. But for 3, you're going to raise your solubility. But I think, I already saw yours. Did you have one for number 2?
Just my full name, but it's
And I think you guys had one for number 2 that worked?
Yeah.
Yep. Oh, except, what's the charge on strontium? It is 2. So where does the 2 go?
The two goes around the side of 3.
Bracket end of 3 2. Because nitrate's only 1. You need 2 of them. Yeah?
Now you're a whole after you just throw it away.
No, no. I mean, they're in the same family. They share a lot of property, but they can be different than soluble. So it's not a common. No, it works. Common means identical. Yeah. Yeah.
Wait, what were you asking?
Your question is equivalent to saying, I mean, people said like we're both at the same school. We have that in common. But if someone went to Shawnigan, they wouldn't have that in common with you. Maybe it's close. For this last one,
For the second one.
NaOH would work.
Okay.
Yeah, so SR plus 2, whoops, SROH 2 goes to SR plus 2 plus 2H minus. A variety of people had this one right. So what was yours that you just gave? And you don't have your phone out, do you? NaOH works because you have the hydroxide in common. And I think I saw quite a number that had SRS. And it also has strontium in common, which in both cases will cause it to shift that way. Now this is the last question I gave you at the end of the day. We want to now do the opposite. We want to increase its solubility. How can we get it to shift right? Either question.
Add SR or OH
To which one?
to the second one. No.
If you write SROH,
We get both of them.
if you have a saturated solution so that nothing more will dissolve, and you add more solid, will more dissolve? No. So adding more SROH won't work.
Can you increase this page?
If you have a saturated solution so that no, yeah, okay. How would you remove the ions? What would you add?
Sodium sulfate.
sodium sulfate. So let's add Na2SO4, sodium sulfate. Does sodium precipitate anything? No. Does sulfate low solubility with anything?
Oh, sorry. No, wait. That doesn't work.
Why doesn't it work?
I was looking at the wrong column.
Is this the double ion effect?
No, I think sulfate might work.
No, it doesn't.
It doesn't?
Because it has low solubility with strontium.
Yeah, that's why it works. I like how you got it right by accident.
You wanna,
Just pretend you did it on purpose.
oh, lower it.
Yeah.
Oh.
If we want to raise the solubility for SR
Add something that's soluble with.
OH2 goes to SR plus 2, this is an equilibrium, plus 2 OH minus, you proposed we add sodium sulfate. Of sodium sulfate, which is the spectator ion?
Sodium.
Sodium. So we don't care about the sodium, it's the sulfate. Does sulfate have low solubility or high solubility with either of these ions? In fact,
solubility with strontium.
it's low solubility with strontium. SR
My bad.
SO4 is low solubility. So if we add sulfate to this, what will happen? What will you get? You'll get a precipitate. Which means what will happen to the amount of strontium plus 2? It'll decrease. If it decreases, which way will the equilibrium shift? It'll shift to the right. And what will happen to the amount of solid? It'll decrease. You'll dissolve more. You have increased the solubility by precipitating one of its ions. It doesn't have a fancy name like common ion effect. It's just an aspect of equilibrium. So you can also precipitate one out to increase the solubility. So to decrease the solubility, you add a common ion. To add to the solubility, you just precipitate out one of the ions. The more you precipitate out, the more it'll dissolve. This is extensively used in mining. You want to get particular particles out. You want to get out all the gold ions. You want to get out all the silver ions, copper, aluminum, whatever it is that you're mining. First, you dissolve them in a solution, usually highly acidic. And once they're all dissolved in solution, you then precipitate out the ones you want at various times. What else could you add? So using the same concept, not allowed to use sulfate. What else could we add? NaNO3 is classic because both of them are spectator ions. Yeah. So for this one, we're looking for something with strontium or hydroxide. I am going to go around the room, and everybody has to give me an answer. Because there is an answer. There are so many answers. So I'm going to go right. You've already given me one, Marcus. What can we add that will precipitate one of those?
NaOH.
You've just used the common ion effect. It'll shift to the left, and you've done the opposite of what I want.
Okay.
Make it shift to the right.
Like SO4, we already did that though.
We already did SO4.
There's not.
Also, maybe this is
Low
just.
solubility. Oh wait. Like sulfide or something like hydrogen. Sulfide.
We are looking at our compound as strontium hydroxide, right?
Yeah.
And I'm hearing a lot of negative ions that you're trying to add to strontium. Why is nobody looking at what will precipitate out the hydroxide?
But aren't we trying to make it more?
Yeah, more soluble. So take away one of the ions.
But it's not.
So like any you could do anything. You could do like Mg
Mg.
hydroxide.
No.
Yeah, so you'd have to add Mg what?
Mg hydrox.
No, that is what you're going to make.
Oh. Magnesium like sulfide.
So what is a negative ion you could add with Mg that doesn't precipitate anything? It's a pure spectator.
Oh, that's participate anything.
Na3PO4.
Wait, what's the other one?
Could you do NaCl?
I'm going to ask everybody. I'm just finishing up with Marcus's. So you want to add Mg.
Yeah.
What's its spectator partner?
Something that doesn't precipitate Sr.
Something that doesn't precipitate, a negative one that doesn't precipitate anything.
Oh.
That's the easiest one to worry about.
I don't know. NO3. Oh, yeah.
NO3.
Oh, it's because
Yeah,
it's all
yeah.
insoluble with everything. Oh my
Perfect.
God.
Because then you will get
Yeah.
2OH minus goes to MgOH2 precipitate. So that will,
Wait, I thought we were doing calcium. Why are we doing Mg?
I feel like you kind of need to tell us what we're doing.
Yeah, I think number 1 and 2
We need to
is
go back.
calcium strontium. No, CAS. That's number 1.
yeah,
So why are
we,
we doing magnesium?
I've been doing it for the
he's doing it for the other equation. So he's doing it for this equation.
the SRO.
And that's the one I put on the board, so I thought that's the one he was focusing on, so that's the one we're doing. You want to do
We're
it
not
for
done the first one.
But what does
it, for both number 1 and number 2. I don't care which one you do, as long as you understand the principle.
Wait, Mr. Dakota?
I don't understand.
No. Okay. Go back to the original. Focus on that equation here.
Okay.
Now,
What does
I'll get in a second. One at a time. Why does sodium sulfate raise the solubility? Look at sulfate. Look at sodium. Does it precipitate anything? Does it react in any way? No. So sodium, spectator. Right? Okay. What does sulfate do?
Oh wait, no.
With what? Is it soluble with strontium? Why are you laughing? No. Strontium sulfate is low solubility, right? So in this equilibrium, if you add sodium sulfate, you will make if you add sodium sulfate, you will make strontium sulfate solid,
Yeah.
right? That means the amount of strontium, the concentration will go down. If it goes down, which way does the equilibrium shift? This way, yeah. Because whatever you do, nature tries to undo that. Went down, it'll shift to the right to try and increase it again.
So why are we adding magnesium?
If it shifts to the right, you dissolved more strontium hydroxide. Right? Right. So you raised its solubility.
So you've done that one.
Yeah.
Okay. Why are we doing magnesium then?
Yeah,
I just
I don't get how like magnesium you want to like make.
so
MgO.
I went that this number 1. I think another confusion is that was his answer, and then I went over to
Oh, we're
his
just
answer.
doing different types.
So we're
Oh,
doing
okay.
different ones. Everybody. Oh my God, was that the only confusion?
Yeah. Sorry.
3.
I thought you kept adding.
I'm going to go
steps.
around to everybody.
We did ours together.
Okay, fine.
And
What are you going to add
Na3PO4.
for this one?
Yes.
Na3PO4, and let me just check. PO4 precipitates nearly everything. So your precipitate's going to be strontium 3 PO4 solid 2. Yep, that would work.
Wait, you want to precipitate it?
If you're going to raise the solubility, you want to precipitate 1 or 2 of them.
That was nice.
Raising the solubility. low solubility is a precipitate. So when you're raising the solubility,
Question number 3.
you try to make more liquid.
Question number 3. The question asked you to raise the solubility of strontium, say, I'm doing this one, strontium hydroxide. So that means you want it to shift right.
So make more liquid.
No, this has nothing to do with liquid. It has to do with the amount, concentration. So liquid doesn't change in this whole thing. So it's not just dissolving more, it's dissolving more per liter. Does that make more sense? So if you want it to shift this way, one way of doing that is to lower the concentration of either of those. So if they add sodium phosphate, then the phosphate will precipitate the strontium to strontium phosphate. That will decrease. If that decreases, it shifts right. You dissolve more, you raise the solubility.
So it turns into a solid.
Yeah, because it went out of solution.
So do you
It's
want
just
it?
worded so weird.
Do you want it to dissolve or precipitate? Like, do you want the SR to dissolve? Like.
You want more of the strontium hydroxide to dissolve.
Okay, but
One way of doing that is precipitating the strontium
so
solid, or precipitating the hydroxide. Does that? So you want this to dissolve, and one way you can do that
yes.
is by getting rid of either one of these.
But I don't get how you're getting rid of it if you're precipitate.
I need an analogy. How can I make? Let me try. I don't think this is working very well. We have Hope and Privet,
Yeah.
best houses, separating out, but only some of them can. We want more of them to be able to precipitate. More of them to be able to come out. So this is in the house, and this is how many fit in the gym. Is this analogy working so far?
So you want more in the.
So I want more in the gym, running around. Okay, rather than sitting at their desks together. Apparently Hope and Privet sit at their desks together in the house. Okay? This setup working? I don't see any nods at all. Okay. How can we fit more Hope Privet? We send in Rogers, and they come in and they grab all the Privet people and they run away. So more people. Hold it. This had 120 people. This only fit 60. Rogers came in, grabbed the Privet people, ran away. Precipitate. Now there's 45. Can we fit more in? Yeah, because we took the Privet people away. They're off playing, I don't know, paintball.
So how are you raising the solubility?
Are we fitting more Hope Privet in?
Oh, by taking away.
By taking away a part,
you can add
more. One person.
But it's like you're taking away an amount just
Yeah.
to add
Yeah.
the exact same.
Yeah, that's all. Yes. Yes.
There's no point to that though.
No, that is the point. Yes.
So you add something that is soluble and then something that's not soluble.
Yes. Yeah.
Okay.
Yeah. I feel at the end, the concept was simple, and I made it really complicated, possibly.
It doesn't.
Like, what's
Do
the
it.
point in doing that?
Yes, it did. Did you fit more people in?
Yeah.
Then you did something. No, don't go. No, don't do that. You did do something because you fit more people in. By taking the privet people away, there's now more room in the gym. Ta-da!
So the pivot people don't matter?
No, of course not. Yeah. Like you fit more strontium hydroxide because you precipitated out the strontium. Yeah, you got rid of strontium to fit more strontium hydroxide. Yeah. I'm going to keep moving that way. You have to give me an example that works. What? CuNO3. That is copper plus 1. Is that what you meant? And copper plus, where's my, I need that too.
But Mg doesn't matter.
So copper plus,
I think what are all spectator?
will copper plus 1 make a hydroxide? Yep, that works. Going, wrapping around? Okay, what is it? Calcium carbonate. Okay, so let's take a look. Does calcium react? Is it low solubility with yeah, that works. That's low solubility. What about hold it. Is calcium carbonate soluble? Calcium carbonate is low solubility, but somewhat dissolved. I'd accept it. You tend to want something that completely dissolves to make it work well. A little bit would dissolve, so it'll be fine. But look at the other one is strontium. So what about strontium carbonate? Is low solubility. So that would also work. The only quibble would be this is also low solubility, so not much of it is going to get in there and do a lot. But as long as some dissolves, then yes, it would work. The theory is sound.
So it works.
Yeah. Did you guys give me an example in all that? I don't think so. Go, an example. BA, you are adding a common ion, which is ship it to the left, which will mean that it lowers its solubility. So can't add a common ion. We're looking for something to make it shift right. Pardon?
So with
CaSO4. So CaSO4 means, yeah, CaOH2. We have already said is low solubility, so that works. SO4 is also less low solubility with strontium.
Is OH not a common ion?
No, this is what you made. Remember, they added calcium sulfate.
Oh, okay.
So they didn't add a common ion. And strontium sulfate is also low solubility. Again, the same quibble though. Calcium sulfate, I think, is also low solubility. It is. So not much would dissolve. So not a lot would dissolve. So it's not necessarily the best type of answer. You want something in which it dissolves completely to be able to do it industrially. Do you have one?
But that was for Ron's equation.
No, never.
I don't.
Can you pick one of those and pair it with something that will allow it to dissolve?
Well, you would phosphate, but then what?
Right. Yeah, so what'll dissolve with phosphate? Pardon?
What cation?
Yeah. What cations are soluble with phosphate? All the alkali ions. Which,
Oh. So you want something soluble instead
Yeah.
of PbSO. Okay.
so it has to, ideally it should be able to dissolve.
Then lithium?
Sure. Li3PO4. And then this will make
Oh, you're right.
strontium 3PO4 low solubility. That works. And that dissolves. So for example, these answers, where we use calcium carbonate, you've actually got two things that work in there. You could just do calcium nitrate. That would work. And for the hydroxide, you could just add sodium hydroxide. Both of them would work independently and probably a little better because they'd fully dissolve first.
But don't you want something with a low solubility?
You,
Like with not soluble?
of the pair, so this
Oh,
is a spectator, and it's just there to carry the phosphate that will be low solubility.
So you just want a spectator and not
Yeah, yeah.
So why didn't Helena's
Ooh, so in my analogy with Hope and Privet, the Rogers boys are going to take away the Privet boys, but they're scared to go to the gym by themselves, so Allard had to take them down. Allard just then takes off, doesn't do anything. They don't take anybody from Hope. But Allard would be like the spectator on it.
So why did Elena's thing BAOH not?
BAOH, because our system is strontium hydroxide. If you add BaOH2, now I think that's low solubility, but no matter how much dissolves, this is already low solubility, but some of it's going to dissolve, and so you're going to make some of this, which is going to increase that, which is going to make it go the other way. They have a common ion. So that is going to lower the solubility. That answers. So for questions 1 and 2, when I said lower the solubility, that'd be a right answer. For question 3, where I'm saying raise the solubility, then that doesn't work. So for this one, instead of adding barium hydroxide, add barium nitrate. No common ion.
But nitrate
But how come
is soluble.
No.
CaSO4 works?
How does what?
CaSO4 works,
There's no common ion.
but it's CaS for the...
No.
No, because we're doing the strontium one. We're doing number 2 because that was the easiest one to see.
So
So you can literally just...
Pardon?
can you use the common ion for this?
The common, no, you're trying to avoid a common
So
ion.
then how does SRSO4 work in that?
No, that's what it made, not what you added. What you added was calcium sulfate. These are the products you made. Very messily, I tried to write made.
Wait, why would BaNO3 work? Because
So,
they're both soluble.
now, no. Nitrate is soluble. It's a spectator ion, so we're going to ignore it. Look up hydroxide and barium plus 2. Solubility or low solubility?
Oh, you can do it either way.
Yeah,
Oh, it's so much more confusing.
yeah. That's
So
I'm
you
spending a
can
bit of
pick-
time.
You
Pardon?
can pick hydroxide or strontium to focus on.
Yes!
Oh, okay.
Yes! You love it. Who said I hate it?
Oh, no,
What are you looking at? You have your iPad
my
out.
notes.
No, you clicked on something.
No, I'm looking at my notes.
Mm.
I pinky swear.
Mm. However, is this better now? Do you understand why barium nitrate works? Okay, back row. K2SO4, yeah, because sulfate works. So if you add K2SO4, so that's what you added. That will make 100% because it dissolves K plus SO4 minus 2. And then in our original compound, strontium makes SrSO4 precipitate. So that will drop and it will shift to the right. Good. K3PO4, we've had phosphate. It will dissolve because potassium's an alkali ion. The phosphate will make strontium phosphate. That works.
Would cesium carbonate work?
Cesium carbonate. Cesium is a alkali metal. Carbonate, we know is now from all of these will precipitate the strontium. That will work. Cesium sulfide. There is no right. This is the one without sulfide. Sulfide does precipitate. No, because strontium sulfide is soluble. So cesium sulfide. If you look on your sheet, strontium is soluble with that. Yeah. You need a pair. If you're gonna focus on strontium, you need a pair that's low solubility.
No idea.
Got your table? Oh, hey. I have so many tables.
Can I just like switch it? Can I do a different one?
Yeah. Do you want to go?
Potassium carbonate?
Potassium carbonate would work. Because we already know that carbonate is low solubility with strontium, so you get strontium carbonate, and the potassium is high solubility, you're good. Is there anyone with more questions on this? Because I feel this is always an area where there's a bit of like, I really felt the whole part where it was like, but you're not really doing anything. Yes, you are. You're taking a small group out to fit more of the whole group in. That's considered something. Anybody who needs another example? Good, bad, indifferent? You've been exposed to an existential crisis and your entire worldview has now changed? Okay. In this section, you're going to see the common ion effect a lot. Whenever you want lower the solubility, look for ions in common. It's going to have an effect. As well, watch out for this, because one last thing, I'm going to use a whole new page for this. If I have and I want to shift it to the right, we have added things that would precipitate the strontium or would precipitate the hydroxide. There's another entirely different class of molecule that would decrease one of those. What is hydroxide? What is hydroxide? It's a base. My hint was going to be something you never drop.
What?
Drop the base. What do bases react with? Acids. So what else could we add to this to decrease the amount of hydroxide? HCl. So that would decrease, add HCl, would decrease the hydroxide, it would shift to the right. So anytime you see an H plus or an OH minus, you can add the opposite. So if you see an OH minus, you can add an acid, hydrochloric, nitric, any of the strong acids. If you see an H plus, you can add base, sodium hydroxide, calcium hydroxide. Later on, you'll learn a whole bunch of different acids and bases. So just to give you a wrinkle, when you look at especially old exam problems, they'll have that too. Okay. 2 more examples. Write the net solubility equation for BR. What could you add to the solutions? PBI2 to lower the solubility of AgCl. What could you add to reduce its solubility? Explain using Le Chatelier's principle. So, we have had a thorough, I think, explanation of this. It is 12:54. I have not yet done attendance. Who's not here?
Sienna.
And
Thanks, Cole.
still away. Anyway, 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
Yeah, why is it Henry P?
What?
Why is it Henry P instead of Preston H?
What are you? Oh, why first name rather than last name?
Yeah.
Because they just told it to.
No, like everyone's name is their first name, and then Preston's his last name.
Oh, because his last name sounds like a first name, and it probably interpreted it wrong and flipped it the wrong way around. Yeah, so you're in there backwards. That's a good thing to point out. Thank you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Perfect. Why don't we say toolkit, group maker, groups of 2. Your group of 2, you can work at a table. You don't have to go up to the board. on a piece of paper, the two of you, bring me the piece of paper with a complete explanation for both of these. As soon as it's good and it's right, you're good to go.
Okay, Adam, let's talk what?
Good to go.
Once you and your partner show me a working explanation and answer.
You got your paper?
And just to make it easy, let's not do the second part. Let's just say lower the solubility of PBI2, just so I can
But do we
focus
still
my
have to write
answer.
the net solubility equation?
And you have to write the net solubility for BrCrO4. What could you do to reduce its solubility and explain it? Find your people, and then bring me your written answer.
Can we have it on two separate pieces of paper?
Sure, I don't think you'll need to.
No, I know, but just so I can work on the second one.
Oh, but you're both going to hand it in. Either one of you is wrong. The first one is the second one's a lot more difficult because you have to include an explanation. Like the two of you should be able to do number one and like second.
Oh. Yeah. I'll write the.
I'm just saying it's an
But the net
unequal
solubility
division.
equation, that's the same, but you put the first thing first, and then it goes. To the
Yeah, you
ion.
put the first thing first, and then the second thing second.
But then it goes into the ion.
And then it goes
instead
into
of the
the
other
things.
way.
Right.
Instead of
Yes.
the ion
Yes.
going into the
Yes.
ion.
Mr. Neufeld,
Yes?
That's the only.
PBI2 is already at a low solubility.
Yeah, I know. I want you to lower it even more. Yeah.
Not soluble.
Sodium iodide.
Something.
Yep. Someone said Mr. Neufeld. Oh, there? Yes?
Could you like tell me if like we're on the right track?
Nope. You can ask another group if they're willing to share with you.
Wait,
Wait.
okay, is lowering the solubility what we just discussed?
So
The first thing we did was lowering the solubility. The second thing we did was trying to raise it.
Wait, so
So you want to lower the solubility. That's an expression of
comma.
You just have to.
Wait, so the net solubility equation. Do you need to add anything to BaCrO4 to get it?
I just want the net. That's just the first thing. Write the net solubility equation. Just write it out.
But it's not going to anything. Like, wait, what? I'm so confused. So it would be. Can you come look?
Okay. I'll put another word in there.
Right next to solubility. What's net solubility?
Yeah.
We often say net solubility equation, and what we mean is the net ionic solubility equation.
Yeah, but wait. So it would go like that.
Looks like you're on the right track.
Wait, okay, I think I got this one.
When we say solubility, it means the solid's on the left.
Hold on.
What? What's so? Am I tweaking?
Solid
I can't
on the
read
left.
that.
it's everything. The complete
Solid on the
Oh wait,
left.
no, it's
Yeah.
it's low.
You just do the fucking. It can't be that.
And then just, yes, it is. It can be.
So, let's find the last.
I think I got this one. H2S.
You got it.
Why is your phone? Don't take out your phones. I'm just assuming you're using ChatGPT
Yeah, and then we need to brand all of these are like
or shopping.
this. Are you sure? Because it says the solids on the left.
What?
I'm working on it.
How is that sexist?
Oh yeah.
I'm not assuming you in general. It was like over there the phone was out too. And the last person I caught was a young man who was buying extremely expensive Nikes. I didn't know that old Nikes that are like 8 years old could be worth $1,200.
What were they? Big dunks.
They were Nikes. Who cares? They're not even built well. Some child slave like built them, and now they're being sold secondhand for $1,200.
Yeah.
Like your stickers.
Like my stickers, exactly.
But those were cheap.
But I have found another supplier of the stickers. Now, I'm not saying that they might be a drop shipper, but I am saying I can't prove that they're not.
Etsy.
So I have plausible deniability. which is how we all get through our day in our first school term.
How are we supposed to know if it's chromium 1 or chromium 2 or 3?
It'll have to be.
That is a weird question, because I don't even know why you're talking about chromium.
I don't think CR's. Oh, what?
I think you might need to review your polyatomic ions.
Wait, is nanionic recanceled out?
CrO4. What?
Is nanionic?
But I don't know what is canceled out.
Oh, chromate. Oh.
There you go.
I see.
Wait, how are you supposed to know what's
This is like,
not
it's like
aqueous?
to make this.
What?
So you have to like make another equation.
What do you mean not aqueous?
Like, how are you supposed to know what you cancel out?
Of what?
Of the nanionic solubility?
You
I
only
don't
have
understand how there's-
barium chromate.
Is this balanced?
When you're done with it, yes?
But there's 4 oxygen, and the charge of Ba is
Wait, what's yours?
-2.
I feel you need to review your polyatomic ions.
What's a
Yeah, it's
polyatomic
just-
ion?
Because the S will precipitate the.
I have a small sword. I'm going to start stabbing you. Turn to the page of polyatomic ions. Turn to the page in your data book, and it says common ions.
Yeah,
Share the knowledge.
Yeah, it's not soluble.
It's
not
chromate.
soluble. S makes them low solubility.
It's not 3 things, it's 1, 2. Chromate. It's CrO4.
We need to do the second one. Which will be how you reduce its solubility.
Yeah, that would make sense.
Okay, so it's the same thing. Yeah.
Okay, and you're showing more.
Looking at space.
What do you cancel out?
Why would you cancel
What's
it?
the charge of 2?
How about I do one on the floor? If I have a compound that was AB, and I was asked to write the net ionic solubility equation, I would write
Oh wait, is complete the one where you cancel things out?
Yeah, so literally.
no, the net is, but the only every time you ever have to do the net in the full way is if you have 2 things you're adding together, you have to figure out which one is the solid. You already know which one's the solid.
Oh.
Yeah, that's just.
There's what I think we have to do. You ready? And
What? Oh, right, probably events for today. Where's, yep, bring it on up.
I think we're done.
alright, you're done. Yeah, we're also done.
First come, first serve.
We need to go. We need to come first.
CBN03 will work. First part right. Second part not.
Damn it.
Hold it. Mail, where'd you go?
I'm here.
You answered the wrong, you gave the wrong answer to this question and the right answer to the third question of the 4.
What?
Part 2? I asked you to decrease the solubility. So you don't want it to shift right, you want it to shift left.
Oh. For the
Wait a
first
minute,
question
run
or the second question?
For part 2 on
We
that.
can't do this though. We have
Yeah, I know, you have to run your meeting. Who is next? Is this both of you?
No, we do it right.
NAI would work, absolutely. You have that, add GAS, the amount of VA, yeah, that would work, perfect, done, good. Very good. You guys can go.
Oh, decrease the solubility.
Yeah. And you just did the right answer for increasing the solubility.
Here we go.
At PDN03, that works. You need to review your polyatomic ions. CrO4 is 1 ion. Adding VAS, as long as VAS itself soluble, you want to add something that is itself soluble. So if it isn't, where's that? soluble, yep, that works, so,
No,
perfect,
it's
good.
over.
Yep.
You know where you wanna go?
Yeah, we're good.
First one.
Yes, that would work. Add H2SO4, nope.
Nope.
There's no common ion there. Where's the common ion? Gotta add a common ion.
What?
And, yep. Oh, hold it, what's I2? That's iodine solid or gas? What does it do? PbI2, that's 2 ions, so what would happen here? 2 and then I minus. But this is right. And add BAS, that works, common ion is present. Cu2, no. There's no common ions. Nope.
At BA.
Is the first one right?
Does BaSO4 soluble? Is it? I don't think it is, show me it is. You just.
What do we need?
Want to say yes to get out of here? KI? Perfect. Oh, you add 2 ways. Sure, that's perfect. Add BaSO4. Is BaSO4 soluble?
BAS.
SO4.
At BAS.
BaSO4 is low solubility, so you wouldn't want to add it.
We can add.
But what you'd want to add is like, that would be perfect. Yeah, that would work. Or, because barium chromate, oh sorry, that's a common ion, and that, or that one, yes. Or you could add barium nitrate, for example. Whose is this? Whose is this? There you go. You guys are good.
Yeah, BAS. You can have BAS.
Yes, that would work.
Perfect, done.
Use the other thing that works.
Yes.
We're gonna do a lab next day. We need to do a quiz.
Are you gonna give that extra back?
Yeah, hold it, where's your head?
You have it.
Do I? I have all your lab books and I'm working through them.
Yeah, you have it.
Yes, take your head back. Because I'm not, I think I went through them.
I don't think they're here.
Yes, they are. They'll be somewhere up there. Hold it.
Test on two.
1 second.
That's where my calculator was.
Mr. Neufeld, we're doing a lab next class, you said?
Yeah, hopefully. Well, and if your head isn't here, grab it. Yes. So what you would add would be, so go ahead and but I want to see the compound you add. So soluble oh, NaI, I didn't see that, so small. This common ion, there's no common ion with copper sulfate.
Yeah.
What's a common ion? There's no SO4 in that. Common ion.
You just do BASO4.
Yes, I don't think Ba is soluble with sulfate, so a better one would be like barium nitrate, BaNO3. Oh, and they're gone.
Thank you, Mr. Neufeld.
Thank you. I think everybody worked really hard today. Do I? You too. Do you have your Hebden?
Me? Oh yeah, I brought it to him because I went to reception, but the lady was gone by the time.
No,
I
you
got
can keep
there.
it.
Oh, I didn't hand it in over break.
That's fine. I don't, someone was saying, can I have it back? I don't think I actually ended up taking it in. And my thought was, well, we already saw it for the test.
Okay.
And I have all your lab books. I'm going through those as we speak.
You gave me my lab book back already.
What?
Yeah, you gave us all of them back.
No, I'm marking your lab books. I have them in the house. Yeah.
Well, you gave me mine back. Mine's marked. Like, it says it has your initials until like the very last page.
Are you talking Hebden or lab?
Lab book.
Bring your lab book next day. I'm doing an overall mark, which is different. Maybe you missed the day that I was doing that.
Okay.
Okay.